All right, let's finish this up then. We are doing the GIS lesson and we've done 2 exercises and we're on to the last. So we're getting to the end of this, and that is identifying which crops are within this range of possible future warming and drying from the joined areas that we've shown here. This is going to be the warmest and driest areas in the world, and I'm particularly concerned about Morocco over here. And so we got to see where the crops might survive. So it asks us to add a vector layer again, and it's using a shapefile called crops. And so we will go up to here. If you don't know what I'm talking about, there are, by the way, 2 previous blunders through that I recorded what I was doing. One is Bumbling Through Global Climate Model QGIS Exercise 1, and I just posted the Exercise 2. It seems to be pending for some reason. Not sure why. Yeah, it's still being processed. Anyway, while that's happening, let's see. So we're in this document here. This is Lesson 1, Global Analysis in Quantum GIS, Exploring Global Climate Model Output, and we're down toward the end. And so we're taking this information and we're going to find the crops. So coming in here, we're going to add a layer, a vector layer, and we're going to find it in here. It's a shape file and it is called crops shape. So we pull that in and just add it. And there's the crop model that came in under crops countries of the world. And so let's see what will work here. The shapefile are 0.5 degree grids in shape. Each attribute is a crop type. The values for each row tells us the fraction that this crop is grown in that grid cell. Let us symbolize the layer crops. So first we're going to open the attribute table and take a look at it, as we always do. And I don't like the color scheme there. I need a gradient green. Makes me feel better because it's crops. All right. Let's look at the table. And barley, canola, cassava, cotton, millet, all these awful annuals that are water intensive. I don't want to grow any of these. Millet, maize, peanuts, oil palm, oh gosh, potatoes, rice, sorghum, rye, soy, sugarcane, sunflower, wheat. Except for the sunflower, there's not a single crop that should be grown. The High Atlas Foundation is doing such a much better job getting people to grow perennial tree-based crops, agroforestry, things like carob or carob and olives and pomegranates and argan and pistachio and almonds and walnuts. Oh my gosh, this stuff is awful. No wonder the world is drying out. So yick on that. But let's see. Look at the disaster. Close the attribute table. Double click on the layer crops and make general option is selected and set up a feature subset because we're only going to map soy agriculture. Oh, yeah, great. Talk about the end of forests because soy is a nitrogen fixer, yay, and that means that the land that's cleared to grow soy never goes back to being forest. As Dr. Susanna Hecht told our classes after she wrote The Fate of the Forest about people who are destroying the Amazon in Bolivia. Oh my gosh. Okay, so we're going to do soy, a dumb example. But with that said, we're supposed to double click on this, and in general, is this general? General information, all right. Yeah, we're on general. I hope it's the same as the older version. It's not the same. Click the Query Builder button in the Feature Subset section. Feature Subset. Query Builder. Where the heck is the Query Builder? Down there. So does it show up in the new version? Go all the way down. No history, links, contacts, fields. It isn't in general anymore. Let's see. Here's a query builder. It's under settings. All right. You got information and source settings. And we're going to click on the query builder. Let's see. Blah, blah, blah. So yeah, click quickly on the query builder. All right, got that. And then In the fields, double click on soy and then click exclamation, which means not equal. Is that what that is? Or I'm not sure what that means. So not equal to negative 99999. All right, so that's what we want to have. Soy not equal to negative 99999, if that means not equal. So soy, and then exclamation point equal. What does that stand for? I think that's not equal to, and I think this needs to be one back. And then what do they want? They want 99999, or they want negative 99999? Negative 9999. Is it 4 nines? Maybe? Just. Yeah, there's a lot of them. A lot of them. No, that's all. So what does that mean? I'm going to ask ChatGPT. Hey, I'm going to do it like this. I like copying and pasting. Copying and pasting makes me happy. So I'm going to copy that. I'm going to say, hey, chat, what do you make of in QGIS? Love to see how the intelligence works on these issues, what it infers. We train each other. Come on. Come on. You can figure it out. You're smart. Soy, not equal to. Soy is not equal to that. You might use this expression, no data or missing data. All right. So it'll highlight all rows where soy field is not empty. Thank you, chat. So if we say OK, and I want to make sure I should say OK at this point, then say OK and then hit apply. It'll remove all features which have a value from our visual display. Will now map only those features which have some soy agriculture. So we're going to go say OK and then hit apply and say OK. So those are the features that have some soy agriculture. A lot of the planet is growing soy according to this. Wow. That kind of stinks. And then we're going to change the style option from single sub to graduated, change the column to soy. So we will go here, double click on crops, and we will go to the symbology. We don't need a gradient fill here. What we need is a solid. We'll apply that. And then we are going to pick in the, I think it's graduated, and the value would be soy. Okay. And what about it? Change the color ramp to greens and change button. Simple fill. Order style, no pen. I really don't get that in this context, but color lines, simple greens, but we don't have those here, so we have to make up our own simple greens. So we can say that, and then we can say that the second part is somewhere like there. Maybe it's not dark enough. Okay. And apply. That didn't do anything. Why? Because we have to classify equal counts. I don't know if we're going to do equal counts. Let's see what they want. The change graduated. The change button. No change button. There isn't any change button. That's interesting. What if we do natural breaks and reclassify, and then we say OK. There. So it looks like the most soy is being grown there where it's dark and the least there. If we really want to change that color ramp, then we should make this and this, make this a more yellowish soy. No, not you. You are yellowish. And then go to green here. Then we can see. Yeah, so that shows where most of the soy is being grown. Should we come in on it? So yeah, the Midwest is a big place there, and then we should also see that China has some dense soy areas because that's where soy comes from, and then Benjamin Franklin brought it to the United States. So we get these different gradations, and then we see how they're destroying Bolivia, etc. I mean, if I go to countries of the world and I select features and I select this country is Bolivia. So Bolivia is not the worst of them then. I mean, obviously the Amazon is much worse. Brazil is much worse. And Paraguay. Brazil is really the one that's been most impacted. And then how do you unselect? I don't even know how you unselect. Deselect. Where the heck is deselect? I never know. Somewhere around here. And it doesn't matter if I select that because this was selected from the select features tool. So there, that's Brazil. Oh, and look at this country here. Yeah, talk about dense soy production. Argentina. Where shall we go next? Argentina. But yeah, clearly Brazil more than Bolivia and Argentina. I still don't know how to unselect something. Maybe there's a way to unselect. I know there's a way, I just don't know. But it is. Sometimes you lose. You're thinking of a different program. Well, I can always go to the attribute table and then deselect from there. Wait a minute. There, deselect. Alright, so that's the most dense area in Argentina. So what are we supposed to do with this data? I'll save this. Well, we should save. And then go back here. And what are the highest concentrations? So we looked at that. Turn on the layer warm and dry. And see, does the highest regions of soil agriculture correspond to regions that may express the most warming and drying? I'm going to do intersect. And intersect will take two layers to extract all features from one layer, which intersects the second. Our first layer will be crops. And we want to extract all crop grids, which intersect with that. And so we're going to double click on the layer crops in order to get the layer properties box. And then click query builder. Click clear. Click OK. Okay, so it wants us to go in here and double click on the crops and find our query builder, which was here, and clear it and say OK and say OK. Alright, because we already have a crops layer with the soybean in it. Now it's telling us to go to the geoprocessing tools, vector geoprocessing tools, intersect. Alright, so we're going to go to, let's close that up, go here and go vector, geoprocessing tools, and intersection. And the input layer is supposed to be crops. Intersect layer is warm and dry. And then we're going to create a warm, dry crops shape. So, over the layer is warm and dry. And then the intersection will be created in a saved file. And it'll be a shape file. And it will be Although, you know, you really should use GeoPackage whenever you can, but we can stay with shapefile if we like. We'll call that warm and dry crops. And we have it in our climate tutorial maps that we create. Warm and dry crops coming in there. Run the query. And wait for it to finish. This time it's not taking as long as the other one did. That one took forever, but it is taking some time, so I'm going to Alt-T and pause. All right, so it's now finally completed that, and it created a layer called warm dry crops right here. And you can see the overlap with the areas. So Morocco is still screwed, that intersection, so southern Spain, and so is the latter part, Texas and California, and so those are very scary areas. So let's see what this is like. Interstellar. Click OK to run the tool. It extracts all the polygons from layer crops which intersect with warm and dry layer. It's going to be all crop polygons of warmer and drier future according to the CSM climate model. When you have to say yes to adding the new layer map, close the intersect tool, turn off the layers, crops in warm and dry. The only one you need to see are countries and warm dry crops. All right, so using the skills you've learned, symbolize warm dry crops using graduated colors. Yeah, let's see. Let's try that. And we can go here and double click. It says you can get rid of that, and you can get rid of that. And all we're looking at is the warm dry crops, but we can come in here in the symbology and take it to graduated, and then do a color ramp and say that the warmest crop, let's go for yellow and say okay, and then let's do an orangish in here. And let's classify under natural breaks. Nothing. Nothing there at all. No breaks. What if we do 10 classes? Right. Nothing? Really? Oh, because I didn't tell it what? Yeah, what we want to do soy. I'll classify. There we go. Apply. So the danger areas are in Italy. Whatever that means, I'm going to have to interpret the data. And over here. I mean, because we have to figure out, like, what does it mean? Warm and dry. So this is a value to 0.14 what? We don't know what the legends are. There's no data here in the lightest color, but here there's 0. I'm not sure what we've combined, to tell you the truth. Intuitively, seems like the places at greatest risk might be these. It's a pretty dire situation. And then they ask us, finally, what are some impacts from warming and drying crops in the US? Which crops are found in the warming and drying areas of Europe? And then you close GIS when you've saved your map. We've exercised 1. We learned how to add vector data to QGIS. We symbolize vector data based on qualitative and quantitative fields. Using the filter and selection tools, you can see the range of possible temperatures and precipitation change a region may experience. And finally, using QGIS's advanced integration tools, we're able to see which regions crop types may be affected by a 2-degree temperature increase and drying by the middle century. It's a great exercise. This has been loads of fun. Loads and loads of fun. And very useful indeed. And I wonder, too, if now that we're doing this, if I selected another crop besides soy for those regions, like what is going to happen to wheat, which stinks anyway. And that's a big problem in Morocco, the wheat. So if I click on apply for wheat, how's it change? Oh my goodness gracious. Oh, not going to be able to get much wheat. Isn't going to do well. There, is it? So definitely dangers. Okay, well. So let's just save this and let's grab this and say warm dry crops. And then let's go in here and say here are wheat crops most in danger according to model. Like that. Put that in there. And I'll put it in our climate. Oh, you know what I could have done? I could have, should have, would have. I should have gone into here. And I could have gone in here and said, hit post, and then pop that in and said, the red, the yellow and red show wheat crops most in danger from the dry, hot conditions anticipated in the near future. This underscores why we must help the High Atlas Foundation in its mission to replace annual and thirsty wheat with agroforestry perennials like carob and tree nuts roots. Let's save it like that. And then and then when we look at the other stuff there, and we go to there. Funny that it doesn't show both of those things, but maybe it will later. Anyway, that's that, and let's also put that into our tutorial. And then let's take that same legend that we put in my Facebook wall. Take that. So you can do your work in several venues at one time and be fulfilling your needs as a student for courses, but also create tutorials of value, create videos, create posts for social media. That's what I'm trying to model that we all do. Otherwise, we're really wasting our time. And there isn't time to waste. This is what's coming. So if you want to avoid another Dust Bowl, if you want to avoid more wars and famines and the four horsemen of the apocalypse, then start doubling down on skill building and sharing. And let's communicate the science. Let's learn the science. Let's be active in our use of the science. All right, I look forward to working with you. This is my attempt to show you how I do my work, how my thought process goes. I open up OBS Studio and I record my voice and I record my screen manipulations, everything I do, and I hit pause when I want to, and I come back and keep recording, and that way you get a faithful record of the amount of time that I invested, and it shows where I was weak and where I was strong, where I was confused and where I was confident. And then we can work, because it's now recorded on the video, we can then work on fixing any problems that there are and any misunderstandings. Like here, with this one, if you go to it, all right, let's continue with, you see that I've recorded all this, and so I spent 52 minutes on the first part of this exercise. So that's roughly an hour, and it actually was more than an hour because I paused while I was looking things up. Sometimes I don't want to record all the stupid maneuvers I make, and when I get interrupted by my son and stuff. But the first part of today was an hour, and then when we look at the second part, it was, this is exercise 1. Actually, the second part was an hour. The third part was an hour and 5. So 2 hours between the two of them. And then this third part is going to be an hour. So all I have to do now is upload this. And it was basically 3 hours, which is a 3 credit hour class in lecture things. So that would earn me at least 6 points for the time I spent. And then I get a point for everything that I've posted, every paragraph. So there's a point or 2 here. And for working on this larger document here. So these are all point-making exercises. So there's the time, 2 points per hour, that now is recorded and shown. And then there's all of this. So I made at least 10 points. And I could probably argue for 20, depending on what I've done with the information and how creative I am. So you never lose anything. If you document what you're doing, you will get the points to get your well-deserved A. You should put in 9 to 10 hours a week into any class, 3 of them being the in-class lectures, and the rest being the work you do creatively on your own or in groups. I hope that helps, and I look forward to taking this journey with you. And remember, use AI as often as possible. Just don't use it to do work for you that you can do. Use it to do the work that you can't. It's a marvelous tool. It's been helping me learn all sorts of stuff for GIS. It is just fantastic. So use these tools. Use everything. Let's get through this climate crisis and draw down the carbon and the nitrous oxide and methane, and let's make sure that we leave a planet worth living on, because we're not going to be able to get to Mars with the billionaires. Who'd want to go anyway? All right, bye-bye.